Hello children, we are going to start with the class 10 syllabus. Light, the chapter in physics, very interesting and very easy. We will study about what is light. Now we all know that anything if you are able to see, and that is because of the light. Suppose you have got a bulb in the room and you are able to see the computer in the room, the walls in the room and other things. That's all because of the light which is emerging out of the bulb which is placed on the roof of this room. Okay, now what happens is light, if it falls on some surface, it will get reflected, and we will today study basically what is the reflection of light from various kind of the surface. Okay, now if you have got the light source, the light is a form of energy that produces the sensation of vision, right? So, and here, if I say that the light has got a property that it generally travels in a straight line. So, if we talk about the rectilinear propagation, that means the light travels in a straight line. Suppose there is a window in the house and the child is sitting and studying or drawing something, the light from the window straightway falls on the paper of the boy. That means the light is traveling in a straight line. Okay. Now, if it falls on the reflecting surface, so the reflecting surface means you have got, this is a plane mirror. The surface on the other side is opaque and this side is the reflecting surface. The light falls on the reflecting surface and that is called as the incident ray. The incident ray, when it falls on the mirror, gets reflected. Now, this green colored ray, which you can see on the board, but actually it is the same color that of the light which is used. So, it is called as the reflected light. The normal is the line which is imaginary and drawn perpendicular to the surface of the reflecting surface, making an angle of 90 degrees. Normal matlab 90 degrees, right? So this line, the pink one, PQ, it is called as the incident, right? It falls on the mirror and gets reflected along the line, that is QR, which is called as the reflected ray. And the perpendicular here, it is called as the normal. Okay, now this phenomenon, what happens is the light is reflecting back to the same medium. So this is called as the reflection of the light. Now the angle made by the incident ray with the normal is called as the angle of incidence, and the angle made by the reflected ray with the normal, it is called as the angle of reflection, right? So now there is something called as the laws of reflection, and according to the laws of reflection, angle of incidence is always equal to the angle of reflection, right? This is applicable to every case wherever the reflection happens. Okay, now we'll talk about the laws of reflection. What does this law of reflection says? The angle of incidence is equal to the angle of reflection. Okay, the second part says the incident ray, the normal to the mirror, and at the point of incidence and the reflected ray all are in the same plane. These are the laws of reflection. Now using this, we are going to study reflection in some more detail, right? Okay, so the making of a plane mirror. Now if you talk about the plane mirror, the light gets reflected from a plane mirror. What is a plane mirror? The mirror which we see every day to comb our hair, to get dressed up. That is called as the plane mirror. It has got a surface which is exactly plain and it is polished on one side and reflecting on the other side. Okay, now this is the plane mirror. Okay, it has got a silver coating on one side and it becomes red. You just see, have you seen the mirror? The silver coating is done on one surface of the mirror and then it is coated with some red paint so that the silver sticks to the mirror and it becomes a reflecting surface on the other side. So this is called as the plane mirror. The chamkila surface, that is called as the plane surface or the reflecting surface. The other part where the silver is coated, then you have got some red paint on it, that is actually the lead It is actually the iron oxide, right? So it is painted out here, so it is sticking to it. So the other side, which is shiny, that is called as the reflecting surface. Okay, now one side the surface is reflecting, the other side it is opaque. That means the light cannot pass through the mirror, it gets reflected, right? Okay, now the types of reflection, if we talk about, it is called as the regular reflection, that happens from a smooth mirror. The rays which are falling parallel to each other, and after falling on the mirror, what happens is all the reflected rays are also parallel to each other. This happens when the mirror is smooth, and the reflection is called as the regular reflection. Okay, now if it is a irregular surface. Now, in the irregular surface, what happens? The surface is rough. So, when the light rays which are parallel to each other falls on the irregular surface, what happens here is the reflected rays are all not parallel to each other, but yes, here also the laws of reflection is followed. Angle of incidence, here also it is equal to angle of reflection. The incident ray, the reflected ray, and the normal at the point of incidence all are lying in the same plane. That is followed. But all the reflected rays are not parallel to each other, because angle of incidence in every case is not equal to the angle of incidence in other case. Right? So you get irregular reflection, somewhat which is seen in the figure like this. Okay. We all have been seeing ourselves in the plane mirror by the time we were very, very small baby. Now talk about some of the characteristics of the image obtained in a plane mirror. How does this image look like? One by one, the first characteristics is the image formed in a plane mirror is erect and of the same size as the object. If you look at as a small boy or a girl in the mirror, the size of the image and your size are exactly the same. है ना? ये तो observe किया ही है. So the first characteristics is the image formed in a plane mirror is erect and of the same size as that of the object. The second characteristics, what you hear, the image is at the same distance behind the mirror as the object is in front of it. What does this mean? Suppose you have got a chessboard which is placed in front of a mirror. Now, if you place a chess Raja in the chessboard, what you can see is a reflection of this chessboard on the mirror. Now, the distance of the object from the mirror is same as the distance of image from the mirror. So 1, 2, 3, and here also it is 1, 2 and 3. So the distance of the object from the mirror is same as the distance of the image from the mirror. Object distance is equal to the image distance. Okay, now this is the second characteristics of the image which is formed in a plane mirror. The third characteristics is the image is laterally inverted. What does this mean? That means if you raise your right hand, it will appear that if it is that you are raising your left hand, right? कई बार ऐसे होता है ना कि एम्बुलेंस हमारे पीछे लिखा आता है तो हमें पढ़ने को मिलता है, रियर व्यू मिरर में पढ़ते हैं तो हमें एम्बुलेंस दिखाई देता है, लेकिन जब हम एक्चुअली उसको पढ़ने के लिए जाते हैं तो उसका उल्टा लिखा रहता है. दैट मीन्स ऐसा लिखा रहता है कि मिरर इमेज लिखा है एम्बुलेंस का. क्यों? क्योंकि हमें दिखाई देना चाहिए जल्दी से और हम साइड दे दें. Right? Okay, so that is called as the lateral inversions. Okay, now let us talk about the question of the same type, which is based on the properties of the image formed in a plane mirror. You have got a plane mirror and a robot is standing at a distance of 8 meters from this mirror. Where is the image formed? At what distance from him will his image be formed? We know that the object distance is equal to image distance. So what is asked? What distance from him the image is formed? मतलब robot से उसकी image कितनी दूरी पर है? भैया 8 plus 8. So it is equal to 16. That is the correct answer. Okay, fine. So simple, na? The object distance here is equal to the image distance. Okay, now what happens is the same robot is moving 2 meters towards the mirror. So what is the distance from the mirror now? Where is the image formed? The object is moved by 2 meters. So now the distance between the robo and the mirror, that is equal to 6 meter. So image is also at a distance of 6 meters from the mirror. So total the image is formed at a distance of 12 meters. Got this? Okay. So hope you have understood this question and the concept well. Now we will now talk about the spherical mirrors. The spherical mirrors are different from the plane mirrors, and how are they formed? To form a spherical mirror, mainly they are of two types. One is called as the convex mirror and other is called as the concave mirror. Now what exactly do you understand by the spherical mirror? The spherical mirror is a mirror which is cut out of a spherical glass object. Okay, now you have got a sphere which is made up of glass, and you take a part of it and cut a certain portion, and the remaining portion, the white portion, is taken out and the red portion is there. So this type of the mirror which is having a shape of a cave, गुफा जैसा होता है. So this mirror is called as the concave mirror. And the other part, if you take the other part, and the reflecting surface is the part which is this side. So this will be called as the convex mirror. Now to understand it more better, let's have this cut into two pieces, and if you have the sphere, you cut the portion out here and silver the side which is inside the sphere. The outer side becomes the reflecting, and this is actually the convex mirror. Again, you take the mirror, cut a portion of it, and you silver the outer portion. The inner portion becomes reflecting. So such kind of the mirror, it is called as the concave mirror. Okay, so the reflecting surface on the concave mirror is outside the sphere, and in a case of concave mirror, the reflecting surface is the inner surface and the opaque surface is the outer surface, right? Okay, now if it happens that some parallel rays go and strike the convex mirror, the light gets reflected according to the laws of reflection. You can see the light which is indicated by the red color, it is the reflected light. Okay, now so what happens is when parallel beam of light falls on a convex mirror, all the rays get diverged from each other. So this is called as the diverging mirror. But if parallel beam of rays falls on the concave mirror, we can see that the rays of light get reflected and all the rays seems coming closer to each other. So this kind of the mirror is called as the converging mirror. Now we are going to talk about the common terms which is generally used in the case of the spherical mirror. Now if you have got a transparent sphere, and this transparent sphere, as I told you already, that we are going to silver it. So the first side, it is called as the convex and this is called as the concave mirror. Now this sphere, the transparent sphere, will have a center. Right. Now this center of the sphere of which the mirror is made up of, it is called as the center of curvature. Now what is center of curvature of a mirror? Is the center of the sphere of which the mirror is a part. Okay, now let's talk about the pole. Now if you have got the mirror, you take out everything and just take the silvered part, and it is the concave part. Now the part of the mirror, this particular part, the center of this particular part, this is called as the pole. The geometrical center of the spherical surface of the mirror is called as the pole. That means you have got the mirror. Take the center of the mirror, that is called as the pole. Okay. Now principal axis. Now what is principal axis? A line which is joining the center of curvature to the pole. It is an imaginary line, right? The straight line which is joining the pole of the mirror to the center of curvature, it is called as the principal axis. Now, the radius of curvature. What is radius of curvature? The radius of curvature, you can see here, it is the red line, right? It is the distance between the center of curvature and the pole, right? Or you can say that the radius of the curvature is the radius of the sphere of which the mirror is a part, right? We have seen the स्पीयर, राइट? तो स्पीयर का जो बड़ा वाला स्पीयर जिससे मिरर बना हुआ है, उसका रेडियस इज कॉल्ड एज द रेडियस ऑफ कर्वेचर ऑफ द मिरर. द रेडियस ऑफ कर्वेचर ऑफ द मिरर इज द रेडियस ऑफ द स्पीयर ऑफ विच द मिरर इज अ part. So while teaching this spherical mirrors, we'll be talking about the center of curvature, pole, principal axis, and radius of curvature. And now you have understood. So if I say again, you will understand what I'm talking about, right? So let's move further. So we will next talk about the principal focus. Now, what is the principal focus? I have got a concave mirror, as you can see in the screen. There is a center of curvature, there is a pole, and there is a principal axis. Now, if I have got ample number of rays which are coming parallel to the principal axis, I know the concave mirror is a converging type of mirror. So all the rays get reflected from the surface of the mirror, and after reflection, all of them are meeting at a point, and this point where they meet, it is called as the focus. Okay. Now, if I have got the focus, look at it. All the rays are parallel to each other and parallel to the principal axis. After reflection, they are all meeting at one point. And this point where the all reflected ray meet, all the parallel reflected ray meet, it is called as the focus. The concave a concave mirror, the reflected rays meet at a point F on the principal axis. This point is called as the focus of the concave mirror. Now, if it is a convex mirror, that means the outer surface is the reflecting surface. So, naturally what happens is the center of curvature falls on the other side because it is on the inner part of the reflecting surface. Okay. Now, it has also got a pole and a line which is joining both center of curvature, and the pole is the principal axis. The rays which are parallel to each other, they fall on the reflecting surface. It's not possible to fall on the opaque surface. It is falling on the reflecting surface, all of them parallel to each other and also parallel to the principal axis. Then what happens is all the rays gets reflected. Now, when the rays gets reflected, they don't meet because all the rays are getting diverged. दूर जा रहे सारे. They are moving away from each other. So there is no possibility that the rays which are moving away from each other will meet. What does it appears to us now? To us, it appears that all the reflected rays are brought to the back and they all appear to meet. They don't actually meet. They appear to meet at the focus. That means you will feel that all the rays are emerging out of the focus. So the point where it happens, all the reflected ray, if extended back, appear to meet at that point, and that point is called as the focus. Okay. Now, convex mirror, the reflected rays do not meet at any point but appear to come out of the point F on the principal axis, and that too behind the mirror. This point is called as the focus of the convex mirror. Right? So all of you are very clear about what is focus? Yes. Now, concave mirror, the focus is real because all the rays are actually meeting at a point. So this point is called as the real focus. And in the case of the convex mirror, the rays are not meeting, but they are appearing to meet. So this is called as the virtual focus. Okay. Now, talking about the focal length, the distance of the focus from the pole of the mirror, it is called as the focal length of the mirror. That means if I talk about the distance, right, let me show you here. You can see that the distance between, it's all coming yellow, just wait. Let me take some other color. Let me take it as blue. Okay. So the distance between the pole and the focus, that is called as the focal length. This is called as the focal length. Okay. Now, in this case, in the case of the convex mirror, there too, it is the same thing. The distance between the pole and the focus, that is called as the focal length. Right? So, clearly understood what is focal length? And there is something very interesting. See what happens. The pole to center of curvature, that is called as the radius of curvature, the focus somewhere falls where? In the middle of the line joining P and C, that is R. So this part, PF is F and FC is also equal to F. That means there is some relation between the radius of curvature and focus. Right? So the radius of curvature is 2 times the focus. So we can say that the focal length is equal to R by 2. right? What is F? F is equal to R by 2. Interesting and very important to remember. Okay? Okay. Now let's do some of the small question. Find the focal length of a convex mirror whose radius of curvature is 32 centimeters. What is the relation between the focal length and the radius of curvature? We know the radius of curvature of the mirror is 32. So what is focal length? Focal length is equal to half of the radius. So F is equal to R by 2, so which comes to be 32 divided by 2, which is equal to 16. Focal length of the convex mirror, it is equal to 16. Simply you can say that if the radius of curvature is 32, the focal length is half, that is 16 centimeters. Okay. Now the focal length of the spherical mirror is 20 centimeters. What is the radius of curvature? You tell me. R is equal to 2 times of F. So that is 2 into 20, which is equal to 40 centimeter. That's it. Right? Okay. Thank you, Bacho. We will be talking in the next lecture about how the image is formed in a spherical mirror. So, go to the next video and watch it. ठीक है? Meet you soon.